Step 1 is bringing your raw data into the workspace. You've collected thousands of raw data points, but to begin the process of refining them, to move them from a chaotic collection into a structured grid, you usually have to rely on expensive, proprietary software. SciDAVis offers a direct alternative. It is a free, open-source, and cross-platform application designed to handle scientific data analysis and visualization without the budget barriers. This comparison shows what we're building today. We are going to take a raw CSV dataset on the left and transform it into a polished, customized 2D graph with a mathematical curve fit on the right. To follow along with this process, you need two things: SciDAVis installed on your machine and a sample raw dataset ready to import. Mastering this straightforward workflow gives you the capability to produce journal-quality graphics entirely on your own. Step 1 is bringing your raw data into the workspace. Navigate to the top menu, click File, and select Import ASCII. Pay close attention to the delimiter settings in the Import dialog box. Tell the software how your data is separated, by comma, tab, or space, to split the information into clean columns. Once you hit OK, the workspace populates as a structured spreadsheet grid. With data loaded, the software needs to know which numbers belong to which axes. To assign these roles, right-click the first column header and choose Set as X. Then, right-click the second column and choose Set as Y. It is a common mistake to skip to finding the X-axis. If you forget this step, your plotting will fail or look completely scrambled. Take a moment to scan your grid. Delete any empty columns or obvious anomalies in the rows to ensure the dataset is accurate. Correctly defining your axes and cleaning your data right here at the start prevents major graphical errors down the line. With your spreadsheet prepared, highlight the exact data columns you want to visualize. Head back up to the top menu, click Plot, and select a basic graphing option like Scatter. The spreadsheet is immediately replaced by a new pop-up window, displaying a rudimentary 2D graph of your plotted points. Plotting the dots is just the first step. To interpret the data, we must mathematically model the relationship between these points using a curve fit. Ensure your graph window is active, then navigate to the Analysis menu and select Fit Linear. A results log instantly opens alongside your graph, providing the mathematical formula and statistical values, like the slope and intercept, defining your regression line. Pairing the visual trend line with these concrete statistical outputs provides the evidence required to evaluate your experimental hypothesis. At this stage, the default graph works for your own analysis, but it does not meet the strict aesthetic requirements for peer-reviewed publication. Double-clicking the axes or data points opens customization menus. Here, you can add bold axis titles, increase font sizes for readability, and adjust colors. Crucially, this is where you attach error bars to your data points. This is a strict requirement for communicating scientific accuracy in any journal. These targeted formatting adjustments ensure the visualization meets the specific legibility and style requirements of academic journals. Now that the visualization is complete, it's time to extract it from the software. Go back to the File menu, select Export Graph, and then choose Current. This dialog box shows your export options. Choose a standard format like PDF and manually adjust the DPI resolution setting to a high value. Configuring a high DPI ensures your detailed formatting and analysis won't become pixelated or illegible when printed in a journal. Navigate to your desktop or save folder and open the exported image file to check its final resolution outside of the SciDAVis environment. This image demonstrates the final result: a high-resolution, standalone scientific graph, successfully embedded directly into your manuscript. With this foundational workflow complete, you can begin exploring the software's advanced tools, like multi-layer plotting or generating three-dimensional graphs for complex datasets. Mastering SciDAVis provides the tools to translate raw laboratory measurements into precise visuals, effectively bridging the gap between your experiments and the wider scientific community.